In our previous lesson, you learned some important terminologies associated with sets. You also learn about the two ways in writing sets. We have the Rosser method and the self-builder notation. You learn about the cardinality of set, the equality of set, the how to represent the element of a set or not element of a set, and so on. So this time we are now ready to study Venn diagram and the operations on two sets. How do we use the Venn diagram to represent relationships among sets and so on. Okay, so we're going to start. Before going further, let us first define universal set. So universal set is the set containing all objects or elements, and of which all other sets are subsets. So we have here an example. Given the universal set, which is represented by capital letter U, which has elements 1, 2, 3, 4, 5, 6, 7, and 8. So again, this is a finite set because the element stops at 8. And another finite set is set A here, which is having elements 2, 3, 5, 7. So when we are asked to draw the Venn diagram for these sets, so this is how it looks like. So the universal set is in the rectangle, okay? Okay, represented by this rectangle. So you put all its elements there, but we have the subset, which is A. So since A has elements 2, 3, 5, 7, so we put it inside the circle. So this denotes that these elements 2, 3, 5, 7 are elements of A, however, are also elements of the universal set or the set U. Okay, now you understand the universal set. Let's go now to the operation of two sets. So we have two operations here. We have the intersection of sets, which is represented by the inverted U. Okay, and the other one is the union of set, which is represented by U. So let's take first intersection of sets. So intersection of two sets, set A and B, is denoted by this one, element of x, such that x is an element of A and x also an element of B. That is an intersection. So when we talk about intersection, we only consider the elements which are both present in the sets, in the given set. Okay, so we're going to understand it more as we go further to the next slide. But for the union of set, we have set A union set B is equal to the element of x, such that x is an element of A or x is an element of B. Okay, so let's take first the intersection of sets. What is this? So the intersection of two sets, x and y, is the set of elements that are common to both set x and set y. So for example, you have two sets here. If x has elements 3, 4, and 6, and y has elements 1, 2, 3, 4, 5, and 6, then what is x and y? So the answer is 3, 4, 6. Where did we get the answer? By looking at these elements of both x and y. So what are the elements common to both? Okay, it's 3, 4, and 6. So when we are asked to draw the Venn diagram, it looks like this. So as you can see, 3, 4, and 6 are in between the two circles here, in which the first circle is for the x set and the second circle is for the set y. Okay, so I think that's clear. So please take note, class, that when you get the intersection of set, when you want to determine the elements for the intersection of set, you only consider the elements which are common to both. Okay. Okay, we're done with the intersection of set. This time we'll go to the union of set. What is this? The union of two sets A and B is the set containing those elements which are elements of A or elements of B without duplication. Take note, without duplication. It is written as A with B, U, and B. You read this as A or B. So example, we have set A 1, 2, 3, 4, 5, 6 and B 2, 4, 6, 8, 10. Find the union of A or B. So the answer is 1, 2. Okay, you take all the elements of A, you take all the elements of B. So you rewrite it in ascending order without duplication. So as you can see, we have element 2 for both A and B, but in our final answer, we just write 2 ones here. Okay, same thing with 6. We have 1, 6 for set A. We have also 6 for set B. But in our final answer, to represent the union of two sets, we only write 6 ones. Okay, again, when we write the union of sets, we take all the elements of the sets without duplication. Okay, so how about when we are asked to draw the Venn diagram of union of set A and B? So this is how the Venn diagram for this looks like. Okay, so please take note of this. This time we'll proceed to the complement of a set. Complement of a set is denoted by this symbol, which is read as A prime or not A. Is the set of all elements in the given universal set U that are not in A. So given set A and its universal set U, then the complement of A is A prime equals element of X such that X element of the universal set and X is not an element of A. So let's take, for example, this one. Let be the universal set equals 1, 2, 3, 4, 5, and 6, and A we have 1, 3, 5. Therefore, the A prime or the A complement is, okay, so what are the numbers in the, what are the elements in the universal set which are not elements of A? So we have 2, 4, 6 only, because 1, 3, 5 are elements of A. Therefore, our answer for the A complement is, or are the elements 2, 4, and 6. Another interesting part of this lesson is taking the difference of two sets. The relative complement or set difference of sets A and B, denoted by A minus B, is the set of all elements in A that are not in B. Please take note. When we we get the difference between A and B, we take all the elements in A that are not in B. So a we have here an example given set A and B. So therefore the difference is, if we take the difference between A and B, so that's equal to an element of X, such that X is an element of A and X is not an element of B. However, when we take the difference between B and A, so this time it's reversed. So it's equal to an element of X, such that X is an element of B and X is not an element of A. Now I know it's a bit confusing for you this time because of these set builder notations, but I know that in the succeeding slide you will learn it better as I show you some examples on how to get the difference of two sets. Okay, so let's proceed. Okay, let's start with these examples. We have example 1, which is adapted from mathisfun.com. So we have two sets here, set soccer, which has elements Alex, Cassie, Drew, Hunter, and set tennis, which has elements Cassie, Drew, Jay. So the problem is find the difference between soccer and tennis, or soccer minus tennis. Soccer minus tennis. So we're going to compare the elements for soccer and tennis, and we're going to eliminate the elements in the soccer set against the tennis set. So solution, soccer minus tennis, the answer is Alex and Hunter. Now how did we get this one? So let's compare again. Let's compare the elements of the two sets. Since we are subtracting, or we are eliminating what's common between the two for the soccer and tennis. So let's check Cassie. Cassie is an element of soccer, also an element of tennis. So we're going to eliminate this, cancel. So what's left now with the soccer? If Cassie is eliminated, is Alex, Drew, and Hunter. So this time we're going to compare the three remaining elements for soccer with the two remaining elements for the tennis. So as you can see, Drew is the only remaining element for soccer which is present in tennis. So we can cancel this out, or we can eliminate this out. So what's left in the soccer set are elements Alex and Hunter. Therefore, the answer is Alex and Hunter. Okay, so now let's revise. What if I want you to find the difference between tennis and soccer? Tennis and soccer. So that's tennis minus soccer. So this time we're going to compare the elements for tennis against soccer. So let's take a look. Cassie, okay, eliminated. Drew are also eliminated. But Jade is the only element for tennis in which soccer doesn't have. So therefore our answer, when we get the difference between tennis and soccer, the answer is Jade. Okay, so when you are asked to draw the diagram for the first example, so the Venn diagram looks like this. Again, the rectangle part, it represents the universal set, and the circles here represent the subsets. Okay, so if you have questions, you may raise it now.